Good morning, students. Today's topic to be discussed is the earthquake. We will discuss what, why, and where aspects of the earthquake here. This is the geographical methods of inquiry. First question is what aspects of the earthquake? Means what is earthquake? Earthquake is the shaking of Earth's surface with tremor leads to the deformation of Earth's land, surface land, collapsing of the buildings, and damaging properties. Now comes to the why aspects of the earthquake. It means why it happens. When the energy released along the fault plane, you can look at this picture. This is the fault plane. It means there is a sharp break in the rocks. When the energy released along the fault plane, when two blocks of the rocks, that is first one is upper block, second one is lower block, move apart in opposite direction. Suddenly, due to intense pressure of gases and magma inside the earth. Actually, the fault plane is stable or balanced by the overlying rocks because of its frictional force. When the pressure inside the earth are intense, then the frictional force of the overlying rocks, which makes it stable, cannot hold the pressure and cause earthquake to happen. And this earthquake releases is the result of release of the energy from the, you can see just bottom of this fault plane in first picture and second picture also. This is the focus from where the sudden movement happens and the release of energy into all the direction. And that release of energy when reaches to the surface of earth, causing damages in the form of collapsing of buildings, damaging of property, and so on. And just perpendicular above the focus or 90-degree from the focus to the surface of earth is known as epicenter, or through another word it is hypocenter. And epicenter is the nearest place to first receive the waves and have maximum destruction. Now come to the earthquake waves. It happens only in the lithosphere part of the earth. What is lithosphere? Lithosphere is the solid upper layer of the earth having depth up to 200 km from the surface of the earth. Now come to the seismograph, an instrument which records the energy or surface or the waves. Seismograph is an instrument which records the seismic waves in the form of curves. You can see here there is a ball attached with the strings. When the earthquake happens, this ball starts moving and it records the earthquake waves into different curves. And these curves have three different sections recorded on the seismograph. Seismograph is a paper where these curves are recorded. And according to this curve, these waves are divided into two types. First one is body waves. Second one is surface waves. Body waves are traveling to the body part of the earth when the energy released from the focus, and it travels all the body parts of the earth. That's why the name suggested body waves. Second one is surface waves. When these body waves, which are generated well inside the surface of earth or from the focus area, and it travels to the surface of earth and interact with the surface rocks and generate new sets of waves and generate new sets of the waves, that is called surface waves. Body waves are also again divided into two parts. First one is P waves, second one is S waves. P waves means primary waves. Second one is secondary waves. Primary waves are faster among the all waves. It is the first to reach the surface and are recorded first on the seismograph. It can pass through all the medium, solid, liquid and gases. It is similar to the sound waves, where the vibration moves parallel to its direction of waves and exerts pressure, that is, squeezing and stretching on the material in the direction of the propagation. Second one is secondary waves. Secondary in terms of it reaches second after the primary waves. It is second to reach the surface of Earth, and it is second to record on the seismograph. It has one limitation, that it can pass only through the solid medium and not through liquid medium. It cannot pass through liquid chamber. It cannot pass through molten state of earth material inside the earth. Now we can face the two different terms which are useful for this chapter. First one is reflection. Reflection means rebound of the seismic wave to its original place. And refraction is change in the direction or slight bending of the waves. Surface waves. Now come to the surface waves. It moves slower than the P and S waves. It means it is recorded last on the seismograph, and it is the most severe ground movements. It causes wide scale destruction of human and property due to displacement of overlying rock. You can see here surface waves which is generated just beneath of earth's layer or crust, just beneath of earth's layer, and causing damages to the human and property. Now we'll discuss the shadow zone through the picture. The shadow zone, the zone over the surface of Earth where seismic waves are not reported. Shadow zone means the zone over the surface of Earth where seismic waves are not reported. Now look at the picture. You can see there's two pictures. First one is S wave shadow zone, and second one is P wave shadow zone. If a seismograph is placed within the angle of 105 degree from the epicenter, the both P and S wave would be recorded. If a seismograph is placed within the angle of 105 degree from the epicenter, epicenter means the point where the seismic waves are recorded first, the both P and S wave would be recorded, beyond of which S wave cannot be recorded. But for the P wave, between 105 degree to 145 degree, between 105 degree to 145 degree are not recorded, because waves are refracted due to change in medium or any other possible cause. The zone between 105 degree to 145 degree is called shadow zone for the P waves, and the beyond of 105 degree S waves are not recorded. You can see here for the S waves, this green lines S wave shadow zone. It cannot cross 105 degree, but it is written here 103 degree. But in the book of NCERT is written 105 degree. Beyond of 105 degree, it is not recorded. But in the case of P wave shadow zone, there is a very small area between 105 degree to 145 degree, but in this picture this is given 103 degree to 142 degree. It is not recorded. It means the seismic waves, that is P waves, are refracted to slight one. That's why this region is known as shadow zone for the P waves. So we came to understand the mechanism of this shadow zone. Now we will study the types of earthquake. What are the different types of earthquake? First one is tectonic earthquake. Tectonic earthquake, these earthquakes are generated due to sliding of rocks along the fault plane, or you can say along the different plate boundaries. Second type is volcanic earthquake. When the volcano gets erupted and the release of energy because of this explosion causes the earthquake to happen. Third one is the collapse earthquake. Third one is collapse earthquake, when the roofs of the mines inside the earth get collapsed, then the energy releases causing the earthquake to happen, causing the tremor on the surface of earth. Fourth type of the earthquake is explosive earthquake. Many countries like India, Pakistan, USA, Russia, these are testing the nuclear bomb, and the nuclear bomb has tremendous amount of energy which are released during its explosion, and it causes tremor to the surface of earth. And the fourth type of the earthquake is reservoir earthquake. It occurs in the areas of the large reservoirs of the water, and this induced the earthquakes. Now we will study the measurement of the earthquake, how the earthquakes are measured. These are measured here is not given, just there are two measurement of the earthquake. First one is Richter scale, or you can say Richter scale. It records the intensity of the scale. The range of the intensity are 0 to 10. Many of the earthquake which occurs on usual are below 4 of the Richter scale, and beyond 8 in the scale of Richter scale are very rare to happen. And the Mercalli scale measures the visible damage only. It measures the visible damage caused by the earthquake. And the range of the intensity scale, or range of the Mercalli scale, is from 1 to 12. And the range of the Richter scale is between 0 to 10. Now study the effects of the earthquake. Actually, the earthquake is the natural hazard. It is caused by the nature, but some anthropological activity like construction of the reservoirs, nuclear explosion or nuclear testing, causing some kind of man-induced earthquake, but largely it is natural hazard. And you can see the effects of earthquake through ground shaking. Ground starts moving, ground starts shaking somewhat. It causes landslide in the mountainous areas. It causes mudslides in the lower hilly region. It causes soil liquefaction, soil becomes mobile and starts sliding down from the upper areas to the lower ground. It causes ground lurching, means sliding of the land through unusual means, and it causes avalanches on the mountains or the icy areas, snowy areas. It causes avalanches. It causes ground displacement. Ground become displaced to somewhat from the original place. It also causes floods in the area of dams construction, when the dams, due to water exerts pressure on the walls of the dams because of earthquake. It causes break in the dam, causing floods in the nearby areas, and it also causes failures of the levee, or levee is the uh, side areas of the rivers, and also cause fires when the earthquake happens, and it causes damages in the town and the settlement areas. Building becomes collapsed and causes some kind of fire due to electricity reaction. And it also causes structural collapses. Many buildings are collapsed, and it also causes tsunami. As you can take the example of tsunami on the coast of eastern coast of India in 2004. A large scale devastation happens on the eastern coast of India, also on the coast of Myanmar, uh, Malaysia, Indonesia. These countries were highly affected by that tsunami. And tsunami happens when the epicenter of the seismic waves lies on the surface of oceans. The effect of tsunami would occur only if the epicenter of the tremor is below oceanic waters and the magnitude is sufficiently high. When the magnitude of the earthquake below the oceanic water or on the epicenter within the oceanic water uh, could be more than 7 on the Richter scale, this causes displacement of the water, and you can say the depth of the oceanic water is around 3000 to 4000 meters. These effects of the tsunami are generated by the tremors and not an earthquake in itself. Though the actual quake activity lasts for a few seconds and its effects are devastating if the magnitude of the quake is more than 5 on the Richter scale. Now the last topic of this earthquake is the frequency of the earthquake occurrence. What is the frequency? Where is the frequency of the earthquake occurrence? Now come to the where aspects of the earthquake. In which areas the earthquakes are very much prone? As it was told, the earthquake, the tectonic areas, or you can say the plate along the plate boundaries, especially the converging plate boundaries, where the two different land masses like continental landmass and oceanic landmass converges or strikes against each other, and this area experiences frequent earthquakes. As you can see the ring of fire zone circulating the Pacific Oceans, And there are many countries like Japan's eastern part of China, Philippines, on the western part of Southern America, that is the Andes Mountain, and the Rockies Mountain lies in the western part of Northern America, which encloses the Pacific Ocean, experiences the frequent earthquakes. And you can see in India, it lies on the plate boundary also. Himalaya lies in the plate boundary between Eurasian plate in the north, and in the southern part it is Indo-Australian plate. In between Indo-Australian plate from the south and Eurasian plate from the north, Himalaya lies, and Himalaya experience the frequent kind of earthquake, or Himalaya lies in the earthquake prone areas. So we covered all the why, what and where aspects of the earthquake. So wait for the next session. We'll discuss the next topic related to this chapter.